Welcome back, guys, to lesson 3.5 about the chain rule. So a couple videos ago, we talked about some of the basic derivative rules in lesson 3.2. So today we're going to talk about the chain rule. So the chain rule is a rule for composite functions that we're going to use those other basic derivative rules to basically put together. So let's get cooking talking about the chain rule. So mathematical formula for the chain rule. So if I have the derivative with respect to x of f of g of x, what I do is I take f prime, I take the derivative of f of g of x. So g of x is still going to be completely inside this first portion of the function, and we're going to multiply that by the derivative of g. I sometimes like to remember this as starting from the outside and working in. So if you remember back when we talked about composite functions, I told you sometimes it might be helpful to recognize a function as a composition of two functions. So what I could do here is I could look at this and I could say if I had the f of x were equal to square root of x and the g of x were equal to 625 minus x squared, then I could rewrite this function right here as f of g of x. And if I wanted to take the derivative of this, this would be f prime of g of x times g prime of x. So right here, if this is f of x, f prime of x would be equal to 1/2 x to the negative 1/2. And then g prime of x would be equal to negative 2x. So what I could do is I have f prime of g of x. So this is 1/2. And then g of x, I'm going to plug in for x. This is 625 minus x squared to the negative 1/2. And then multiply this by g prime of x, which is negative 2x. So I could simplify this. Negative 2 times 1/2 is negative 1. So I can simplify this as negative x over the square root of 625 minus x squared. So when we take a look at this, really what we've done is we've taken this whole thing and we've taken the derivative of the outside portion. So the square root part first. This is 1/2 times, don't mess with this inside function. This is 1/2 times 625 minus x squared, because right here we're just applying the power rule. And then I'm going to raise this to the negative 1/2. Now I'm going to multiply by the derivative of the inside function, 625 minus x squared, which is negative 2x. And this is another way that you could apply this without necessarily having to recognize the composition of the functions. You still need to understand that this is a function inside of a function without explicitly writing out the composition of the functions. All right, so we're just going to look at some examples. So we're going to practice doing this. So for example, in this one, I have ln of cosine of x. So first I want to start by looking at ln. So the derivative of ln, that's 1 over x. So this is going to be 1 over cosine of x times, now I want to multiply by the derivative of cosine of x. This is negative sine of x. So I could just rewrite this as negative tangent of x. So the derivative of ln of cosine of x, I could rewrite that as just negative tangent of x. Derivative of the outside, ln, the derivative of ln, 1 over x. X in this case is cosine of x times the derivative of the inside function, negative sine of x. All right, so we're going to practice a few more applications of this. So this one, so I'm going to start by recognizing I'm going to have to apply the quotient rule. So if I'm applying the quotient rule, I have low. So I've got x times square root of x squared plus 1 times 2x. That's the derivative of the numerator. Or sorry, times 2x, the derivative of the numerator. So low d high minus high x squared minus 1 d low. So here's where the chain rule and the product rule are both going to come into play. Product rule, I've got 1 d2. So I've got x times the derivative of this portion right here. So this would be outside function as the square root. So this would be 1/2 times x squared plus 1 to the negative 1/2. So I've got 1 part of d2, because now I still need to multiply by the inside, so that would be 2x. So I've got 1 d2. Sorry, I ended close the parentheses too soon. This is the first term times the derivative of the second plus, nope, that was the right parentheses. That's closing that parentheses right there. Plus 2. So I've got square root of x squared plus 1. d2, the derivative of x is just 1. So I've got that whole thing over x squared times x squared plus 1. That's the denominator squared. So we could go through and simplify some of this, but basically the big thing I wanted you to see here is right here in this denominator. When I'm taking the derivative of that, I apply the product rule. So that's 1 d2. This portion right here is the derivative of the square root of x squared plus 1 plus 2d1. So right here, this portion right here is where we applied the chain rule to take the derivative of this term. All right. So we're going to look at one more example. And again, I'm going to start on the outside, work in. I've got cosine. So first one, take derivative of cosine. Derivative of cosine is negative sine. So I've got negative sine of ln of x times the derivative of ln of x, which is 1 over x. So I could just write this as negative sine of ln of x over x. And that would be the derivative of f. So I know that this is not necessarily intuitive for a lot of you guys. This is the first time that you've seen something like this. So we will do plenty and plenty of practice with this, and practice is what's going to really get you used to doing the chain rule. But today's topic was just about the chain rule. In class, we're going to do a bunch of practice and exercises to make sure that we understand how to apply the chain rule. If you have any questions, make sure that you bring them to class. And I hope you have a fantastic day. I'll see you next time.